in this circuit we are required to find the potential difference between the points M and N. So in order to solve this problem, we should know certain things in circuit analysis. So this is a capacitor circuit. So first point to note here is that in the case of a capacitor, this is a capacitor. Now in the case of a capacitor, the plate which charges enter is the positive plate and the plate from which the charges leave is the negative plate. That is the convention that we are going to follow. The plates to which charges enter is your positive plate and the plates from which the charges leave is your negative plate. So in this circuit, if this is the direction which the charges are flowing in the circuit, then this is your positive plate and this is your negative plate. That is the first point. Now the second point is, when you are traveling from the positive plate to the negative plate of a capacitor in a circuit, there is a loss in potential, because the positive plate is normally considered to be at a higher potential than the negative plate. Therefore, when you travel from the plate with a higher potential to the plate with a lower potential, there is a loss in potential. So if the charge here is Q and the capacitance of the capacitor is C, then we will write here V equal to minus Q by C. Why minus Q by C? Because you are traveling from a plate of higher potential, higher voltage, to a plate of lower voltage. So there is a loss in potential. On the other hand, suppose you travel from a plate of lower voltage to a plate of higher voltage. You walk like this. Then there is a gain in potential. So the voltage will be written as V equal to Q by C, because you are walking from a plate of lower potential to a plate of higher potential. So there is a gain in potential. This is applicable in the case of batteries too. Suppose you have a cell like this. This is the positive terminal, this is the negative terminal. While walking through the cell, if you are walking from the positive terminal to the negative terminal of the cell, again there is a loss in voltage. So here we will write minus V as the potential drop. Similarly, if you are walking from the negative terminal to the positive terminal through the cell, then there is a gain in voltage. So this will be plus V. So I hope everything is clear for you now. These are the requirements that, or these are the things that you should know beforehand while in solving a capacitor circuit. So now let us start our solution here. And for that, what we are going to do is this. There are many ways by which this circuit can be solved. You can apply Kirchhoff's voltage law throughout the circuit, but I am not going to do that. I am going to replace the two cells with a single cell and calculate the equivalent capacitance of this circuit. So this is 31 volt and this is 7 volt. They are connected in such a way that their positive plates are together and negative plates are together, which means that these are two opposing PDs. So the two cells are opposing each other. Therefore, the net EMF of this combination will be E net, or E equivalent will be 31 minus 7, which is equal to 24 volt. So that is the net EMF or the equivalent EMF for the combination. Now let us look at the capacitors. Now you see that once you replace these two cells with a single cell of EMF 24 volt, you can see that all the 5 capacitors are now in series. So we don't have to check whichever are in series and whichever are in parallel, because you have removed the 7 volt, 31 volt and replaced them with a single cell of EMF 24 volt. So all the 5 capacitors are now in series. So 4 and 4 in series is 2, 2 and 2 in series is 1. So we have 1, 6 and 1.2, which is 6 by 5. All of them are in series. 1 and 6 in series is 6 by 5. This is 6 by 7 and this is 6 by 5. So what is the equivalent capacitance of these two? 1 by C equal to 7 by 6 plus 7 by 5, which is 7 by 6 and 5 by 6. This is actually 5 by 6. 7 by 6 plus 5 by 6. So this is equal to 12 by 6, and therefore C equivalent will be 1 by 2 microfarad. So that is the equivalent capacitance of this combination. So we have replaced the 5 capacitors with a single capacitor of capacitance 1 by 2 microfarad, and the equivalent EMF of the combination is 24 volt. So what is the charge flowing in the circuit? Q equal to CV. So this is equal to 1 by 2 plus 20 into 24, which is equal to 12 microcoulomb. So the charge flowing in the circuit is 12 microcoulomb. So we see that the charge in the circuit is 12 microcoulomb. That is the charge. Now let us apply Kirchhoff's voltage law between the points M and N. So we are now going to apply Kirchhoff's voltage law across the points M and N. So we start our journey from M and walk towards the 4 microfarad capacitor. So you see that this is your positive plate and this is negative because we have replaced the 31 and 7 with a single cell of EMF 24 volt, and the positive of the 24 volt is here, where the positive of the 31 volt is now. So remove the 7 volt from here and replace the 31 with the 24 volt. So this is your positive plate and this is negative. You are walking in the direction of the decreasing potential. So we will write Vm minus Q is 12 by 4. Then you walk through the cell again in the direction of the decreasing potential minus 7. Now you come to the 6 microfarad capacitor, again the direction of the decreasing voltage, which is 12 by 6. That is equal to Vn. Therefore, Vm minus Vn will be equal to, all of them go to the other side of the equation. This is 3 plus 7 plus 2, which is equal to 12 volt. So we get the potential difference between M and N as 12 volt. That is our final answer.